Right, acids, bases and salts. Here we go. Explain the difference between a strong acid and a weak acid. Okay, just got to remember this. A strong acid is fully ionized in solution. Okay, and a weak acid is partially ionized. That'll get you the 2 marks. But as always, just say a bit more. Just let the examiner know that you know what an acid is, and say that therefore a strong acid has more hydrogen ions in solution, because that's what an acid is. An acid is something with hydrogen ions in solution. Okay, so a strong acid is fully ionized. Okay, a weak acid partially ionized, and therefore the strong acid has more hydrogen ions, in other words H+ ions in solution. Good. Right. Give a reason why adding hydroxide ions to an acid solution leads to an increase in pH. Okay, it's only 1 mark, but we're going to give a good explanation so you fully understand it. So, as always, try and use the word therefore rather than the word because. If you use the word because, it stops it dead. But if you say therefore, then you can say therefore something else, then therefore something else, and get to the conclusion. So, we shall say that hydroxide ions, that's OH- ions, that's what a base is, essentially. Something that provides hydroxide ions. Okay, and an alkali is a soluble base. Okay. Hydroxide ions react with hydrogen ions to form water molecules. Okay, that's what acid and base reactions are all about. That's the acid, that's the base, and look, HOH forms H2O. Okay, so hydroxide ions react with hydrogen ions to form water molecules. Therefore, you write out the word therefore, I'm just going to do it shorthand. Therefore, the hydrogen ion concentration is reduced. Therefore, the pH is increased. Okay, that will definitely get you 1 mark, but maybe in your particular exam it'll be a 2-mark type question, so that's how you should approach these sort of questions. Say what you know and try and use the word therefore. Okay, therefore this, therefore that. Right, write the balanced equation for zinc oxide and dilute nitric acid making zinc nitrate. Okay, so zinc oxide and dilute nitric acid, HNO3. What's that going to make? Well, that's a base, okay, and that's an acid. It's an acid-base reaction, and you need to know this equation for whenever you mix an acid with a base. Acid plus base always makes salt plus water, okay? Acid plus base goes to salt plus water. So, we've definitely got water here. Now what's the salt? Well, it's going to be zinc something. Nitrate. But hang on, we're not finished. We have to check that we have the right number of nitrates, okay? And we do that by using our knowledge about the charges on these things. Let's start with oxygen. You know oxygen is always 2-, okay? So for this to be balanced, the zinc must be 2+, right? Therefore this zinc is 2+, okay? You know that H, there's only one of them, well, I mean, sort of irrelevant. H is just 1 plus, okay? Therefore, the NO3, the whole thing if you like, must be 1 minus. So look at this. That's 2 plus, but that's 1 minus, which means we must have 2 of them. Okay? Because that is 1 minus, so when you've got 2 of them, it balances the 2 plus. And water's neutral. So that's how you should work out if you have the right number of things sticking onto the metal. Okay? So now we've got the right number of little numbers. Okay? Now we have to balance it and make sure we have the right number of big numbers. The right number of, in other words, the whole thing. The big number tells you how many of the whole thing there are. Right. So, start from the left. 1 zinc here, 1 zinc there. That's fine. 1 oxygen there, 3 oxygens there. So 4 oxygens on the left, but 3 times 2, 6 plus 1, 7 on the right. Okay. So we're going to have to add some more oxygens here on this side. Now, let's not do it there because that would change the number of zincs and they're okay. So let's do it here. Now, there's 2 nitrogens there and there's 1 here. So let's add a 2, okay? And then recheck. So this is our first attempt. So when you've added a number, go back to the beginning and recheck. So 1 zinc on the left, 1 on the right, that's fine. Right, how many oxygens? 1 plus 2 times 3, so that's 7 on the left. 3 times 2 plus 1, 7 on the right. Good, the oxygens balance. Hydrogens, 2 on the left, 2 times H, and none there, 2 on the right. Hydrogens balance. It's just the nitrogens now. 2 nitrogens on the left, 2 nitrogens on the right. That's it, it's balanced. So we just had to add that 2. Now, if you're looking at the mark scheme for this specimen paper, it's wrong. They had a 2 there, okay, and that is not correct. That is correct. Good. Right. Next question. We have 50 cm cubed of potassium hydroxide, okay, 50 cm cubed of KOH, and a concentration of 40 G decimeters to the -3 grams per dm cubed. Calculate the mass of potassium hydroxide that must be dissolved in water to make 50 cm cubed of solution of this concentration. We just have to find the mass, okay? That's the volume, that's concentration, what mass of KOH is in that volume. To do this, you look at the units, right? So, firstly, let me just make sure you understand this. 40 G dm to the -3, that's exactly the same as writing this, 40 grams per dm cubed. Okay, that's what -3 means. And I'd like you to write it like this, G per dm cubed, okay? Don't write it at an angle, write it horizontally like that, like a fraction. Because that's going to help you get the answer. By looking at the units, you know what you have to do in order to get something that is in units of grams, because it's asking for a mass. So we want to be left with grams, which means you want to kill off the cm cubed and the dm cubed. So, look at these two. You know that if you have cm cubed on the top, cm cubed is volume, and you multiply by this thing, 40 G per dm cubed, okay? we've got volume on the top, volume on the bottom, they will cancel and we're just left with grams. So that's how you know to multiply in this case, by looking at the units. Right? Now I haven't done it yet because we have one more thing to do first. We have to convert these both into the same unit, either convert them both into cm cubed or dm cubed. You can't cancel yet because they're not quite the same. They're both volume, so we definitely multiply, but first we have to do a little trick, and this is how you should do it. This is how you convert from cm cubed to dm cubed, okay? What you do, you need to remember, so just go off to the side on the page, okay, and write this down. You need to know that 1 dm cubed, well, a dm, what's a dm? 1 decimeter, it's deci, it's 10, okay? So let's start from the beginning. 1 decimeter, okay, 1 dm is 10 centimeters. Okay, so let's go from there. So therefore, 1 decimeter cubed is 10 centimeters cubed. Okay, so therefore 1 dm cubed is 10 centimeters cubed is 1,000 centimeters. 10 centimeters all cubed is 1,000 centimeters cubed. Okay, divide both sides by 1,000 and therefore we get 1 over 1,000 dm cubed therefore is equal to 1 cm cubed. So if you can't remember that, that's fine. Like I say, just go off to the side on the page and write this down and you'll get there. Just all you have to remember is that 1 dm, 1 decimeter is 10 centimeters. Therefore 1 decimeter cubed is 1,000 centimeters cubed. And therefore, by dividing both sides by 1,000, you get 1 cm cubed is 1 over 1,000 dm cubed. So you have to get to that point there. Okay? And now we can just sub in 1 cm cubed into here. We're going to sub in that. So therefore we get 50. This is like 50 times 1 cm cubed. Okay? So it's 50 times 1 cm cubed, which is that. 1 over 1,000 dm cubed. Okay? Times 40 g per dm cubed. Technically, I shouldn't really have written therefore there. That is equal, all of that is equal to that. Okay? Good. So, now we've got dm cubed on the top and dm cubed on the bottom, and we can cancel. And we're left with just grams. Okay? So, that becomes 50 times 40 grams over, it's just 1,000 on the bottom. Okay? Do a bit of cancelling. 0, 0, 0, 0, which is equal to 5 times 4, which is 20. Still got grams. Over 10 on the bottom. Boom, boom. So that's equal to 2 grams. Okay? So that's how you should do these sort of questions. Remember that. Okay? And just go off to the side on your sheet and write down the whole thing if necessary. That's absolutely fine. But maybe try and remember that 1 cm cubed is 1 over 1,000 dm cubed. Just write that down on the side and then you can sub in and cancel correctly. Good. I shall now clean the board. Okay, final bit. Salts of metals can be made by reacting one of the metal compounds with the appropriate acid. Plan an experiment to prepare pure dry crystals of magnesium sulfate by reacting a suitable magnesium compound with a suitable acid. You may use equations if you wish. Okay, so it's just a standard preparation of salts question. In this case, the salt is soluble. Right, so we've just got to churn out our knowledge in an efficient and complete manner, nail 6 points. So, we're making magnesium sulfate, okay? That's MgSO4. So, what are we going to react together? Well, look at that, it's a sulfate. Can you think of an acid that involves the sulfate? It's got to be H2SO4, hasn't it? Sulfuric acid, okay? Now, what are we going to react it with? You've got a number of choices. It doesn't matter which one you pick, okay? You can react it with magnesium oxide, okay? You can react it with magnesium hydroxide. You can react it with magnesium carbonate, or you could react it with just pure magnesium, okay? Whichever one you choose is fine, it's up to you. So whichever one it is, write down the equation first, okay? So what are we going to get in each of these cases? You've got to get the equation balanced and correct, okay? It's an acid-base reaction. And what did I say? Acid plus base goes to, do you know it? Salt plus water. So, let's get rid of that. What's the salt going to be? And water is just water, isn't it? So, salt, magnesium sulfate, MgSO4. That's 2 plus, SO4 is 2 minus, so that balances, and that just leaves H2O. Okay? Right, what about this one? H2SO4 plus magnesium. Well, it's going to be magnesium sulfate again. I mean, that's what we're trying to make, right? So it better be. Magnesium sulfate. Now we've got 2 oxygens and 4 hydrogens. That's convenient. So it's going to be 2 H2O, 4 hydrogens, 2 oxygens. H2SO4. Well, okay, obviously magnesium sulfate. So this is acid carbonate reaction. Now, a carbonate is a base, okay? So it's still an acid-base reaction. It's just carbonate is a particular kind of base. It's the kind of base that releases carbon dioxide. So it's still acid plus base goes to salt plus water, but it's acid plus carbonate goes to salt plus water plus CO2, okay? So it'll just be H2O, so salt, water, CO2. And that balances, because the CO2 leaves behind 1 oxygen there and 2 hydrogens there. So that's correct. H2SO4 plus magnesium is going to give you magnesium sulfate. Okay, that's not a base by itself. Okay, you're dropping a metal in acid here. And what happens when you put a metal in acid? You get a salt and it releases hydrogen gas. Okay? Right, so in answering this question, it doesn't matter which one of these you pick. Don't write all 4 down, okay? You just have to pick one and talk about that. You'll still get the full 6 marks. So whichever one you pick is fine. So you've written the equation down. Again, just one of those 4, not all 4. And then the first thing you say, you add an excess of the solid. Use the word excess. It impresses the examiner and gets you lots of lovely marks. Gets gets him on your side, okay? Add an excess of whichever one of these, okay? I'll just write a solid, okay? Right, yes, you have to say that the acid is warm. It's not super essential, but that's what they teach you. Just write it down. Add an excess of the solid to the warm acid. Okay, this is just standard textbook stuff. You just got to remember this and regurgitate it in an exam. This is like a classic preparation of salts question. Add an excess of solid to warm acid until some solid remains, was undissolved. Okay? I know that technically excess implies this, but so you don't technically have to write that, but write it anyway, just to show the examiner you know what excess means. Okay? Right. Now, this is for, well, it's for all four really, but it's more applicable to the first two because they're not releasing gas. Okay, that's a gas and that's a gas. Okay, so the only way, oh, and stir. The only way that you know you've had an excess is when some solid is remaining and it's not disappearing, reacting any further as you stir, because it remains, which means you've had an excess of that, so there's no more acid left to react. Okay, now you still definitely write that for these two. Okay, just get that sentence down no matter which one of these four you've done. But you can also say that for these two, that one and that one, you, like I say, you would still write add an excess of solid to warm acid until some solid remains and stir. You could also say, or until it stops bubbling. Because that also implies that all the acid has reacted. No more bubbles, these are gases, no more bubbles are appearing, then all the acid has reacted and you have an excess of this, of either that or that. So, but when it stopped bubbling, you're still going to get an excess of solid, which is why I say write that down for both of them. Well, for both, I mean for no matter which one of these four you choose. By both I meant either that or that. Okay, so get that sentence down, but if you're choosing one of these two, the ones with the gas, then it's also, I would encourage you to also say, just maybe even in brackets, until it stops bubbling. Okay, let's move on. Right, and now it's just the standard experimental procedure for making an acid, making a salt, sorry. Now, pay attention, this is important. It's important to be aware of whether you're preparing a soluble salt or an insoluble salt, because that affects the experimental procedure at this point, okay? This is a soluble salt, and that basically means that we don't refilter and wash it. You can't wash it with water because it's soluble, you'll redissolve it. You can wash an insoluble salt, and I don't want to go into the experimental procedure for that too much now, because let's just get this done. It's a soluble question. You can wash an insoluble salt because it's insoluble, you won't redissolve it. But you can't wash these, you just have to, after the crystals appear, you just dry it, okay? So, the first thing you do after it's stopped bubbling and solid remains is filter off the excess solid. The solid meaning one of these four, okay? Filter off the excess solid, and then you add to an evaporating basin the liquid and evaporate it, okay? Just you can maybe put it in a warm environment if you like, or you can just leave it on the bench. You can put it in a slightly warm oven, which sometimes is the same oven you use for drying it. Doesn't really matter as long as you explain something like that, okay? Crystals will appear. All the liquid evaporates off, okay? You're left with crystals. So you get crystals of what you want, the magnesium sulfate. Crystals appear and you have to dry them, okay? And you can dry them in a warm drying oven. They're not, I know it's called an oven, they're not very hot, they're just slightly warm to encourage the drying. So a warm drying oven maybe. Or you can just use a towel, paper towel, but it's a bit naff. I think the warm drying oven is probably best. Or you can just leave it on the bench. But yeah, that's best. Okay, so that's it, right? This is how you prepare a soluble salt. Just remember this experimental procedure, okay? And just regurgitate it. Regurgitate exactly that in the exam and you get the full marks. Okay, but you have to get the equation correct as well for full marks. Good, okay, so that's it. Okay, I just want to finish off by making sure you know why this procedure is different from the one used for insoluble salts. The reason is, start again. Okay, I just want to finish off by quickly making sure you understand why this procedure is different for preparation of insoluble salts. This is for soluble, okay? So for soluble, you add the excess of solid, blah, 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 all that. You filter off the excess solid, you evaporate and dry, okay? Now, with insoluble salts, you would filter off the excess solid, okay? You would evaporate to get the salt, okay? But then you would refilter to get rid of the little bit of remaining liquid, okay? And then you would wash the salt with a bit of distilled water, okay? And then you would dry. So for insoluble, after evaporating, in here, there's an extra filter and then wash, okay? But that's insoluble, okay? Don't worry about that too much. So make sure you understand this question in soluble. Good, there we go. That's it.